Say you wanted to find out what the voltage is at a particular point on a circuit, you can use nodal analysis to solve it, I guess. The rules used to solve the nodes use the concept of Kirchhoff's current law and Ohm's law to create equations. Kinda like this. Well, I hope this made sense. If you made it this far into the video, I should probably thank you for watching it, really. Where'd that shitty music go? Ah, here. Alright, that probably didn't make any sense to you at all, so I'll actually go back and explain the concepts properly this time. Do I really have to do this? Alright, let's go back to the very start. So as the name suggests, we're analysing nodes. Now you're probably thinking to yourself, what the f*** is a node? Well, a node is basically what you would call a junction or an intersection in a circuit. Specifically in between components of a circuit. Kinda like this, or this. You get it? You probably don't, but I'm just going to keep going on with the concept anyway, because that's how university works. Alright, so to do this, you're going to start by labeling the nodes. Usually V1, V2, V3, and so on. Just on a side note, to make things easier, for a node directly connected to the ground or negative terminal of the source voltage, you can just label that as 0 volts, if you want. The next step is to assume the current directions. Now, it doesn't matter if they're right or wrong in the end, just as long as it's a consistent direction the whole time while you're making the equations. If it does turn out to be the wrong way, you'll just get a negative value, but the magnitude of the current will still be correct. So now that you have this, you make your KCL equations where you're entering current to positive and you're leaving current to negative, and then you just turn that I into a V over R, where the R is just the resistor value, and the V is just the voltage from minus the voltage to. Now, out of everything, that's probably the most difficult part to understand. So I'll explain that part in detail, just so you don't have an excuse to have no idea what's going on. What a dog! Okay, see on V1 how on the left hand side I just have E minus V1 over R1? The E just refers to the node between the voltage source and V1, the from voltage in this case. Since there's no components between E and R1, the voltage at that node is just equal to E. As for the 2 voltage, that's just V1, since that's the direction we've defined the current to be travelling with respect to that resistor. V2 is very much the same as V1. Moving on to V3, however, notice how on the right hand side, the numerators of both I values is just equal to V3 minus 0? Well, that's because the V2 value is actually directly connected to the negative terminal of the voltage source. Now to find these V values, you just use basic algebra. I'm not going to show you how to do that, because if you're watching this video, you should probably already know how to do that. Anyway, that's pretty much the entire basis of nodal analysis. I pretty much have nothing left to say, so go enjoy what you're going to do after this video. I'm done! Here's the outro for real this time.